Greetings, my name is Edor Gabriel Poesina and I'm a PhD student at the University of Bucharest under the supervision of Professor Dr. Radu Tudor Ionescu. In this video, I will be presenting our research PQPP, a joint benchmark for text-to-image prompt and query performance prediction, which we have co-authored with my PhD colleague Adriana Valentina Costache, Professor Dr. Adrian Gabriel Chif from University Aix-Marseille, Professor Dr. Josiane Mott from University of Toulouse. No other work has explored the relationship between query performance prediction and prompt performance prediction. Are these two tasks related, or do they require specifically trained models? And could the QPP model be used for prompt performance prediction or vice versa? In this sense, we have a threefold contribution. We introduced the first joint benchmark for query and prompt performance prediction. We offer a database of approximately 10,000 prompts with more than 1.5 million manual annotations collected, and we introduce multiple baselines for both post and pre-retrieval and generative scenarios. Prompt performance prediction has a rather short history as it has been introduced just in the recent years, while query performance prediction is a task which had the attention of the research community of retrieval models. To collect our dataset, we've selected approximately 10,000 captions from the dataset MS-COCO, where we ensure diversity, while also selecting 200 prompts from the dataset Drawbench, which are more suitable for generative tasks. In terms of the generative model studied, we selected Glide and SDXL, and for retrieval, Clip and Blip2. For the prompt performance assessment task, we have employed multiple annotators whom we require to analyze the relationship between a prompt and the 4 generated images, 2 by Glide and 2 by SDXL, while also requiring them to analyze the relationship for the original image of that specific prompt. We have asked them to categorize into 4 different categories, which are high relevance, low relevance, no relevance, and unrealistic. At a minimum, we have required to collect at least 3 annotations for each of the 5 images specific to a prompt. To ensure the quality of annotations, we have also required to have a Cohen-K agreement of at least 0.4 with a set of hidden control prompts. Out of the 173 recruited annotators, only 147 were validated. For the query performance assessment task, we have required to collect the data for the same set of prompts, while this time the set of possible matches and images to be annotated was up to 2,000. We have collected approximately 1.4 million manual annotations, and we've also employed the criteria for exclusion, which is required that the F1 score with a few control prompts needs to be higher than 0.4. In this sense, we have removed approximately 7 annotators. We've studied both the pre and post scenarios for both generation and retrieval. For the pre scenarios, we have employed the basic text predictors and the fine-tuned word, while for the post scenarios, we've employed the fine-tuned clip model and the correlation-based CNN. In terms of results, we can see that the fine-tuned clip dominates across the board. This is most likely due to the fact that post predictors have access to more information. We can also observe the fact that fine-tuned BERT has a rather high score on a few retrieval tasks, and this might hint us that some prompts might be very unique and could hint us that they're very difficult to retrieve. In terms of the relationship between the two tasks, we can observe that even though we have obtained statistically significant numbers, the correlations are quite low. We have also performed a qualitative study, and we observed that retrieval models tend to fail whenever minute details are requested, while generative models seem to have trouble whenever the model needs to understand various actions. Both types of models fail whenever complex scenarios are requested. We showcase a few applications of our research. On the left, we suggest the usage of pre-generative prompt performance prediction to select an appropriate generative model depending on its expected performance. We suggest that the predicted score should show us if a lower cost model could be used to generate a good enough result, while for the more difficult prompts, we can fall back to a more powerful generative model. We also suggest the possibility of using large language models to rephrase our initial prompt into multiple variants and assess the predicted performance of those variants. This can help us guide the generative model into constructing a more desired result. Thank you very much for watching this video, and I hope that our research has aroused your curiosity. Please find our research at the following GitHub link.